This video has to do with adding and subtracting radicals. Last week we talked about radicals. To quickly review radicals, you have a radical symbol, you have an index, and the stuff that's underneath the radical symbol we call the radicand. If you do not have an index, then you have an imaginary 2 there, which just means that you are looking for pairs of numbers that are the same. You can only combine like radicals. So your like radicals have the same index and the same radicand. Before you get ready to add or subtract like radicals, you have to simplify everything first. To combine like radicals, you're going to add the coefficients and you're going to keep the same radicand. So when you think about like radicals, they're very similar to like terms. So for example, if we saw something like 2x plus 7x, we would add the coefficients out front to get 9, and then we would keep the x. Like radicals are the same way. So if we saw something like square root of 2 plus 3 square roots of 2, we would add together the numbers out front. If a number is not there, it's an imaginary 1. And we would say 1 plus 3 to get 4, and then we would keep the square root of 2. So to look at another example, 2 square roots of 45 minus 2 square roots of 5. The first step is always to simplify. So we're going to simplify by using our factor trees. So we'll start with square root of 45. 45 will break down to 9 times 5. So then I have 2 square roots of 9 times 5. I have to keep the 2 out front because remember, when I do a factor tree, all I'm doing is rewriting what I have. I'm not changing anything about the value, I'm just rewriting what I have. But if I leave that 2 off, then I've changed the value of what I have in that space. So I can continue breaking down my factor tree because 9 will break down to 3 times 3. And I can't break down 5, so I bring down 5 so that it's on the same row. It's important to make sure that you are bringing down things even if they're not able to be factored, because if you leave something kind of dangling up in the air, you might lose it whenever you get to the last step. So then I have 2 square roots of 3 times 3 times 5. Once I get to this point, I can't break down 3 and I can't break down 5. So then I'm going to look at my index. My index, if it's not there, is an imaginary little 2, which means that I need 2 numbers that are the same in a group. And so if I look at the numbers that are underneath my radical, I see that I have a group of 3s. So I'm going to keep that big 2 out front, so keep the coefficient of 2. And in parentheses, I'm going to put 3, cross out 1 from that group. So remember, I'm taking 1 from the group, crossing out the other that's in the group. And anything that did not get circled is going to stay underneath the radical. So I'm going to have 2 times 3 square roots of 5. So all I've done is I've rewritten this 2 square roots of 45 to be 2 times 3 square roots of 5. Over here, the negative 2 or minus 2 square roots of 5, that will not break down because 5 is a prime number. So I'm going to leave that. So I can simplify this by saying 2 times 3 to get 6. So 6 square roots of 5 minus 2 square roots of 5. And then using the rule I know about like radicals, I just have to worry about the coefficients out front. So 6 minus 2 gives me 4, and then I have to keep the square root of 5. So my answer is 4 square roots of 5. On the next example, negative 3 square root of 12 plus 3 square root of 3 plus 3 square root of 20, I'm going to start by breaking down the 12. So 12 will break down to 6 times 2, so I'll have negative 3 square roots of 6 times 2. The 6 will break down to 3 times 2. I bring down that 2, and so I'll have negative 3 square roots of 3 times 2 times 2. So again, I'm going to look at my index. If it's not there, it's an imaginary 2, so I'm going to find two numbers that are the same to put in a group. So I see that I have a group of 2's, so I'm going to keep the negative 3 out front, and I'm going to put 2, cross out a 2, and then square root of 3 inside a set of parentheses. So I put that stuff in parentheses just to kind of keep it all together so that I know that all of this 2 square roots of 3 in the parentheses represented that square root of 12 that I started with. 3 square root of 3 I don't have to worry about because 3 is a prime number, so I can't break that one down anymore. But I can look at 3 square root of 20 and see that 20 will break down to 4 times 5. So I have 3 square roots of 4 times 5. The 4 will break down to 2 times 2, and I can't break down the 5, so I bring it down. So that gives me 3 square roots of 2 times 2 times 5. I'll look at the index. If it's not there, it's an imaginary 2, which means I need two numbers that are the same to put in a group. So I see that I have a group of 2's. So I'm going to keep the 3 from out front. In parentheses, I'm going to write what I have left over whenever I simplify the square root of 20. So I write down a 2, cross out the other 2 that's in that group, and keep the square root of 5 underneath, or keep 5 underneath the square root because I didn't have another pair for that. So then I'm going to put everything together, and I'm going to bring this straight down since I wasn't able to simplify it any. So then I can kind of clean up the things that I have just a little bit. So negative 3 times 2 gives me negative 6 square roots of 3. I still have that 3 square root of 3. And then 3 times 2 would give me 6 square roots of 5. And so then I can see that I have like radicals in the ones that have square root of 3. So negative 6 square root of 3 and positive 3 square root of 3 can be put together. So I'm going to deal with the coefficients out front first. So negative 6 plus 3 would give me negative 3. Keep the radical with the 3 underneath. And then because I don't have anything else to add to this 6 square roots of 5, my answer is just negative 3 square root of 3 plus 6 square root of 5. On number 1, I see that I have 2 square root of 5 plus 4 square root of 5. So I see that my radicands underneath my radical symbol are not able to be broken down anymore. So now I'm just going to combine my coefficients. So 2 plus 4 gives me 6, and then I keep square root of 5. On the next example, I see that my radicands are both 3. I can't break down 3 anymore because 3 is a prime number, so then I'm going to combine my coefficients. On the square root of 3 at the beginning, I don't have a coefficient there, but I know that if there's not a coefficient there, it's an imaginary 1. So I have 1 square root of 3 plus 9 square root of 3. So I'm going to combine 1 and 9 to get 10, and then I keep my square root of 3. Four square root of 7 plus 6 square root of 7. My 7's are prime, so they will not break down anymore. So then I say 4 plus 6 to get 10, and I leave square root of 7. On the next example, 7 square root of 2 plus 5 square root of 2 plus square root of 2. I see that all of my radicands are 2, so I'm going to be able to combine them since they are like radicals. I need to worry about my coefficients next. So I have a 7, a 5, and an imaginary 1. So 7 plus 5 gives me 12, plus 1 more gives me 13, so I have 13 square roots of 2. Square root of 3 plus 3, square root of 3 plus square root of 3. I would add my coefficients there. See that my radicands are all 3, so I don't have to worry about breaking those down any. And then I say 1 plus 3 gives me 4, plus 1 more gives me 5. So 5 square roots of 3. Six square root of 5 plus square root of 5 plus square root of 5 plus square root of 5. All my radicands are 5, so I know that those are like radicals. Now I have to worry about my coefficients. So I have a 6, imaginary 1, and an imaginary 1. When I go to add those together, 6 plus 1, 7, plus 1, 8, plus 1, 9. So 9 square roots of 5. On the next one, I see square root of 7 plus square root of 2 plus square root of 7 plus square root of 2. So I see that my radicals, or my radicands, are all prime numbers, so they can't be broken down anymore. And I see that I have like radicals in the square root of 7, square root of 7. And then square root of 2 and square root of 2 are like radicals. So when I combine my like radicals, I'm going to do 1 square root of 7 plus 1 square root of 7 to give me 2 square roots of 7. And then 1 square root of 2 plus 1 square root of 2 to get 2 square roots of 2. Square root of 3 plus 2 square root of 3 plus square root of 2. I see that all my radicals are prime numbers, so they can't be broken down anymore. Then I'm going to worry about which of my radicals are like radicals. So I see the square root of 3 and 2 square roots of 3 are like radicals, and then that square root of 2 is kind of by itself. So then I'm going to worry about my coefficients on my like radicals. So this is a 1 square root of 3 plus 2 square roots of 3, which will give me 3 square roots of 3. The square root of 2 has an imaginary 1 in front of it. Not that that helps me a lot because I don't have anything else that goes with square root of 2. So my answer is just going to be 3 square roots of 3 plus the square root of 2. On my last example, 4 square root of 2 plus 9 square root of 2 plus 3 square root of 2, I see that my radicands are all prime numbers, so they can't be broken down anymore. I also see that they're all the same number, which makes them like radicals. So then I just have to worry with the coefficients out front. So 4 plus 9 gives me 13, plus 3 more gives me 16. So 16 square roots of 2.